Hello and welcome to my talk about how to keep your ECU secure against compromised adaptive applications. My name is Udo Neitzel. I work at ITK as expert cybersecurity engineer for a couple of years now, and I am a member of the working group security since 2018. And in this working group, we elaborated the concept of identity and access management. And this is I would like to motivate you and to show you in this presentation. ITK concentrates within the Bosch company group, we concentrate on the white box engineering. So ITK itself does not concentrate on product development, but instead we support our customers with engineering support. So the IP usually stays in your company. So if you need expertise in different industries spanning the topics, you can ask ITK for support. Today, I will talk about how to keep your ECU secure against compromised adaptive applications. So I talk about ECUs in the mobility sector based on adaptive AUTOSAR platform. I will give you some motivating aspects about security and identity and access management in detail. I will give you some hints on and aspects why it makes sense to reconsider security with a shift from the classic AUTOSAR platform to the adaptive platform, and how the identity and access management solution especially can help you to keep your ECU secure. A new aspect in the IAM specification is the remote access control. This is an additional topic, and then I will give you a little conclusion what you can should take away from this talk. With a shift from classic ECUs to adaptive AUTOSAR adaptive ECUs, you should reconsider security under some aspects. And one of those aspects, especially, is the co-location of different platforms or different domains, functional domains, on a single computer hardware platform. When you look into the classic AUTOSAR world, you have one-purpose ECUs usually. From one domain, it's either safety critical or it's an infotainment related application that is hosted on one platform. Nowadays, you will see a shift from this single-purpose ECUs to multi-purpose ECUs, and you have co-location of complete platforms like multiple classic AUTOSAR platforms on one hardware, but even more, you have multiple domains within one ECU when you switch to the adaptive AUTOSAR platform. Here you have multiple applications, so-called adaptive applications. Can be with very different domains. You can have safety-critical adaptive applications side by side to infotainment applications, and those applications, the functionality, and so the character of your ECU and your project is even not determined necessarily during development time of your project, but adaptive applications can be added in field. So this results in a very dynamic ecosystem, and as said, you have different security or different domains, and so you have different security domains in your system. Let's assume you have, for example, an infotainment application with very heavy multimedia parsing code, which makes those applications a little more error-prone than really under security aspects designed applications, like, for example, diagnostics application or safety-critical applications. So we assume that an attacker is under control or takes control over this infotainment application by buffer overflows, for example. In this case, if you have no further security measures, the attacker will be able to influence all the other applications. The attacker can exhaust resources, CPU, RAM, can call interrupts, or can misuse interfaces exposed by the other adaptive applications. And additionally, the stack itself provides some functionality That's the idea of the adaptive platform. So you have communication management, you have platform health management, and some other services that can be added flexibly. The attacker can misuse those interfaces as well to disturb the functionality of your ECU. And without any further security measures, this results in a situation that the weakest application determines the level of security of your overall ECU. This is because the attacker only has to get control over one application in order to influence the functionality of all other applications. Why should you reconsider security, or why do you have to consider security at all? Of course, there are some legal and industry requirements nowadays. So besides your motivation to keep your ECU secure, you have to fulfill some regulations, and you will have problems to go in through projects, software development projects, ECU projects, if you don't have security engineering processes established nowadays. And this is based on the UN ECE cybersecurity regulations 155, 156, and strongly coupled to that the ISO 21434. Besides those development and update-related regulations, you have in Europe at least the GDPR, the General Data Protection Regulation. So you are put into responsibility to protect your customers' data. And in order to do so, you need some security concepts in order to, especially for the cases that you have an attacker in your system, to breach the consequences of those attacks. So if an attacker controls one adaptive application, he should not be able to gain access to information that is not related to this adaptive application. But in order to implement your security concepts, you most probably need some support from the platform. And one of those concepts I have in mind is the separation of domains and the assessment and the control of access of your adaptive applications to resources exposed by the platform or by other adaptive applications. And this is where identity and access management comes into the game. I would like to show you the problem so identity and access management of the adaptive platform tries to solve. Of course, IAM cannot solve all problems, so I want to set the scope here. When you look into software development projects nowadays, and even if you have adaptive AUTOSAR applications, different domains, you will face very different development teams and very different companies in your portfolio of development teams. On the one side, you will have teams which concentrate on security for a couple of years or a long time, and have pretty good security engineering processes established. On the other hand, you will have very new companies who didn't concentrate on security because it was not necessary or not considered necessary. And so they are they are beginning to think about security. So you will have a wide spread spectrum of quality with the companies in your software projects. But even those companies who concentrate on security for a long time will have nowadays to include complex software from libraries or from other projects. And the huge amount of code included makes it very reasonable that you have to expect that you may expect vulnerable code. So the more libraries are included, the more projects you have in parallel on your ECU, the most probable it is that at least one of those applications is attackable and compromisable. Yeah, and last but not least, you have to consider some malicious actors in your supply chain. Of course, you can have really malicious actors, but on the other side, you must not expect really malicious intent. But simply backdoors, debugging capabilities, or the desire to gain access on some customer privacy-related data makes it probable that there are some interfaces that are not considered in a security model. And so this is what we call malicious actors in the supply chain. So there is functionality that is exposed that gives access somehow to those companies or third parties. Yeah, so you have, coming back to our example with the infotainment application, you consider a hacker in your system, and of course you can simply isolate this application from other applications, but this is not the idea of adaptive AUTOSAR. Of course, you have some legitimate access, and yeah, this is what IAM gives you. It gives you a meaning of whitelisting according to the principle of least privilege. So you can define for each and every application, adaptive application, which interfaces are allowed to use and which are not. Yeah, according to the principle of least privilege, you have the whitelisting of functionality, and this is already implemented in some functional clusters in AUTOSAR. First of all, we have the service-oriented communication. This was the template solution we developed IAM for this functional cluster first. And you have, in this service-oriented communication, you have different methods, fields, and events. And with IAM, you can restrict adaptive applications access on specific methods, fields, and events. So in case of an attack, the attacker will not be able to gain access to some methods the original application was not intended to. Yeah, same for persistent data. So you can restrict access on files, in other words, and there is platform health management. Platform health management is a distributed state machine which keeps track about the state of your ECU across different applications. And IAM makes sure that applications reporting states can be identified in the first place, and that only legitimate states are reported by those applications. The diagnostic interface is another example. So not every application should be able to gain access to those diagnostic capabilities. And here you can point out one feature of IAM or one non-feature. IAM is not about identifying users of diagnostic interfaces, of diagnostic protocols like UDS, but it gives you the possibility to restrict access to diagnostic capabilities of the platform to your diagnostic application. And this application can do user authentication and authorization, but only this application. Yeah, and then you have raw data streams, so you can restrict opening sockets and communication application by application. Yeah, how is this implemented in adaptive AUTOSAR? So in general, we follow the pattern of reference monitors, and in this model, you have somehow a resource that is requested from an untrusted subject. Untrusted subject here means that you assume that there might be an attacker or a malicious actor. So every access attempt by this untrusted subject is intercepted by the trusted reference monitor. Yeah, and this trusted reference monitor, of course, is configured or has to be configured. This is a whitelist. This is done by policy or called policy. And so in AUTOSAR, the name for the reference monitor is the policy enforcement point. Yeah, translated to adaptive AUTOSAR, this means that you have here the untrusted subject, the adaptive application, which tries to access the functional cluster functionality. You have here the policy enforcement point. The policy decision point is just a helper method. This is optional, but makes the model very clear. The policy decision point holds the processed application manifest, which is the policy in the end. And so this way, the IAM is configured. Of course, those applications are cryptographically signed because they come with the adaptive application package. This is like in your smartphone world. So the adaptive application comes with its configuration, but of course it is signed by a third party in this case. Yeah, so we have simply a request for the resource, then the policy is checked, and only if the policy explicitly allows this access for the identified adaptive application on the expressed resource, then the request is performed. In adaptive AUTOSAR, you have services. They are used via ARACOM, and there is one case that you can have adaptive applications that consume services, and on the other side, you have applications that serve services. Yeah, and so this is covered by IAM as well. In this case, you have two policy enforcement points, which of course can be fused, yeah, so that you don't have extra process switches. In this case, the request from the application is checked. Is this application allowed to access a certain resource? On the other side, you have the question, is this application allowed to serve a service, to provide a service? So, and if both is allowed by the policy, then the request is fulfilled. It is important to point out that both steps are transparent for the adaptive application. So you, as a developer of applications, you don't have to implement any IAM code. So this is absolutely transparent. The PEP is implemented in the stack, and applications simply do their request as without IAM, and then IAM, the PEP is executed within the stack. Same applies for the consumer as for the service instance. There are some scenarios and some functional clusters that are not provided by processes in the AUTOSAR Foundation, but by the operating system. This is true for the persistency library, for example. Here, of course, the persistency library is just executed in the process space of the adaptive application, so you cannot implement the PEP within the application or within the persistency functional cluster. In this case, you have the operating system itself as a trusted reference monitor, as a policy enforcement point. And of course, in this case, security management somehow will configure the operating system, so setting permissions on files, for example, so that during the request of the application, the Unix discretionary access control, for example, can enforce your policy. In the next chapter, I would like to show you the modeling or the configuration of identity and access management. This is done using RxML. So if you are familiar with the modeling of AUTOSAR, then this will look very familiar to you. If not, then just concentrate on the semantics. The idea of adaptive applications or of permissions for adaptive application is very similar to the well-known concept in the smartphone world. So if you deploy or you install an adaptive application, the application itself comes with a list of requested permissions. You don't have to type the permissions in parallel, but the application comes with a list. This list, of course, is cryptographically signed, so the application itself cannot manipulate it. Then, during install time, the user, the installer, will have to revisit this list of permissions and accept those permissions or reject them. And this is exactly what we do in adaptive AUTOSAR. Here we have some different steps. So we have the software development phase, we have the application design phase and the integration phase. And all of those phases have to be considered for the modeling. So again, if you are familiar with the modeling, this looks this looks familiar. If not, I will just show you what you configure in the different steps. So during the software component phase, those are reusable code chunks of code that are developed mainly independent from your application project. You will use port prototypes, and those port prototypes are classes that are the link between your application code and the functional clusters of the platform. So, for example, if you want to use ARACOM, you define a port prototype, or you use a port prototype, and via this port prototype, you can access the platform. So at this point, we added the client com spec and the member client intent. And this client intent, again, can link to a specific client server operation. And this means that on this port prototype, a specific method, for example, will be accessible. It is intended that this application or this chunk of code, this component, will use or will need a specific method. This is just an intent. This is not This is not directly resulting in a permission, but this is just a very abstract request for a permission. In the application design phase, when those components are aggregated and composed, an executable will be created from those functions. And so the adaptive application designer will collect all those intents and translate them to grant design elements. So in the end, you end up with an executable with a list of grant designs, and those grant designs again point to specific client-server operations. In the last step, the integration, so this is what you would call the installation in the smartphone world. The link is created between the processes, which are instances of executables, to the specific deployment of ARACOM, for example. So here you have the grant element, and the grant element links between the adaptive application process, including the grant design elements, and links them to specific service instances. You have seen this, for example, this might be another adaptive application. So with this modeling, now you have, during the component development intents, those intents are aggregated for the adaptive application, and during install time, you link the requested permissions to a specific service provider. And so now you have the semantics of a permission, of a whitelist. So the process, the application represented by this process, is allowed to access a specific service instance. Yeah, so all of those phases are considered now. And of course, all of this will be supported and has to be supported by an according tool chain. But this is true for all our XML configuration parts. This is the job of the tooling to provide a good and understandable user interface. So in many cases, a lot of those steps I showed you can be automated step by step. Until now, we concentrated on access control for local adaptive applications, but there is one additional aspect, the remote access control. Remote access control shall not identify and restrict access of local adaptive application, but remote applications or remote ECUs. And this is the second important aspect of IAM. So you have this scenario, you have the adaptive applications on different ECUs. And on ECU B, here in this case, it shall be checked if an according application on ECU A is allowed to access a certain service. This shall prevent, of course, unintended access on resources provided by ECU B. And it shall prevent denial of service attacks by checking permissions, according permissions on ECU A. And the third is to check on both sides, on the local side and the remote side, if an application is allowed to trigger a request or to fulfill a request. So again, you have here two PEPs on ECU A. The PEP checks if the adaptive application is allowed to request, and on the other side, you have the check if the application is allowed to provide a service. One, and second, if the remote ECU is allowed to access a service. Yeah, this is configured by manifests, and this is a drawback, or one. Let's don't call it a drawback, but at the current status of development, manifests are not synchronized. Or synchronized by means of OEM projects or in the context of your project. So AUTOSAR does not provide a synchronization mechanism. So you can assume those manifests, so the policy to be synchronized statically. And this is why this concept is called a static configuration of remote IAM or SCREAM. So you can imagine the feelings when the colleague got the task to develop this concept. Yeah, with SCREAM, you can define on ECUB, for example, a list of other ECUs and applications that are allowed to access a service. Here, in order to do so, of course, applications and ECUs have to be identified, and reuse the secure communication channels that are already modeled. For example, TLS. So remote ECUs and adaptive applications are identified using certificates or pre-shared keys. Yeah, and the modeling, this is pretty much the same. You remember with the grant element, you link applications to permissions or to services. And here you have, in this example, the remote identity, which is an IPSEC remote subject, and you link it to your local service deployment. So it's pretty much the same. You link not to applications, but to remote. And that's the charm of the solution. The modeling between the modeling of local applications and remote application is pretty much the same. So identity and access management gives you the opportunity to restrict access of attackers in your system by defining whitelists. This allows you to enforce policies and according to your project and your project needs. You can define which, you can assess legitimate access, define it in a policy, and IAM helps you to enforce those policies. This massively restricts the potential opportunities of an attacker in the system, since an attacker, of course, can abuse the interfaces the original application was intended to request, but no additional resources. So if you have an attacker, malicious actor in your infotainment application, the hacker will not be able to control the brakes, for example, or gain access to customer data in other contexts. The security configuration is considered in all steps of the development. So it is easy for component developers to express what they need in an abstract manner. And in the integration phase, spanning to the integration phase, the integrator can very specifically define what this request or this permission means in the actual project context. And all this is done with the well-known modeling approaches, which makes integration into tool chains very easy. Yeah, but still, IAM does not cover everything. So it is just one building block for security. It's on the one side, it is based on some other features and properties of the adaptive platform. So proper isolation, secure communication, secure boot, and secure update concepts. This is what IAM is based on. On the other side, other mechanisms and other functionality like user identification and authorization is based or can be based on identity and access management. So IAM is one brick in the system of security. Yeah, the modeling itself you have seen is pretty complex. But as for all other modeling elements in the adaptive platform and in the classic AUTOSAR platform as well, this has to be supported by the tooling. So the stack vendors and the tooling vendors have to give good and understandable user interfaces so that it is easy for engineers to understand the consequences of their requested intents, for example. Because a fool with a tool is still a fool. So the challenge for future projects is to assess the permissions of adaptive applications correctly. So you have to define what is the necessary access, which access is allowed, and this is not only true for development but also for specification when it comes to the integration of IAM to other functional clusters. So really defining the needs to assess the policies, that's the challenge for future projects and future specification. Yeah, that brings me to the end of my presentation, how to keep your ECU secure against compromised adaptive applications. I hope you now understand the title and the context or the relationship to identity and access management. And yeah, I'm looking forward to your questions in the Q&A session. Thanks a lot.